Welcome to Study Loop.
Good day. In this question, we are told that carbon tetrachloride was an active chemical ingredient used in fire extinguishers to extinguish electrical fires. However, it is no longer in use because of the formation of a toxic gas phosgene that was released when in use. So, in this question, we are going to write down the Lewis structures for carbon tetrachloride and for phosgene. And phosgene is Cl2CO. So to begin with, we need to calculate the total number of valence electrons. So the number of valence electrons for carbon are 4, plus for chlorine it is 7 times the total number of chlorine atoms in that compound, which is 4, and that gives us a total of 32 valence electrons. Then the next step is to write down the least electronegative atom in the center, and then the surrounding atoms, which are chlorine atoms. Followed, the next step is to put the 2 electrons that form the bonds in between, and that gives us 2, 4, 6, 8 electrons. Carbon is now stable, and then the next step is to fill the octates for the surrounding electrons. And that is the Lewis structure for carbon tetrachloride. For phosgene, we need to calculate the total valence electrons for that compound. That is 7 valence electrons for chlorine multiplied by the 2 chlorine atoms, plus 4 valence electrons for carbon, plus 6 valence electrons for oxygen, giving us a total of 24 valence electrons. Carbon is the least electronegative, therefore we write our carbon. Then we have our chlorine atoms on either side and oxygen. Then the next step is to put down the 2 pairs, the pairs of electrons that form the bonds in between using a straight line, followed by filling the octates on the outer electrons. So that's 2, 4, 6, 8, 10, 12, 14, 16. Meaning to say we have 8 electrons remaining. And we put a double bond over there. So now that's 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and 24. And that is the Lewis structure for phosgene.